Okay, so today's lesson really has to do with inverse graphs and inverse functions. Okay, so 2, 7, 22, inverse relations and inverse functions. Okay, now put both words down, inverse relations and inverse functions. Sorry, it's so sloppy. I need to remember to try and write more neatly, okay? So I put two things. I think it's really important. I want to show you a couple of different things, okay? So what's an inverse of a graph? Okay, so that's where every point P, which is some x, y, and I'll slow down, let you catch up, okay? So every point, we're just going to switch the x, y. That's it. It's as easy as that. So we're going to go and it's inverse P negative 1. Okay, that's the symbol. It's up above. It's an up above negative 1. It's not down below. Becomes the y comma x. Okay, so that's how we do it. So do all functions have an inverse? The answer is no. No, 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 no. Okay. And I'm going to give you an example of that, okay? So, example 1, find the inverse of this relation. Okay, so output negative 2, negative 1, 0, 1, 2. So if I were to put the inverse, my inverse would be this. We're going to switch them, and I'll have then my new x and my new y would be negative 8, negative 6, negative 4, negative 2, and 0. And my new y's would be the x's, negative 2, negative 1, oops, negative 2, negative 1, 0, 1, and 2, okay? So graphs both sets of points. Okay, so I'm going to use two different colors because colors are always really helpful for me. So I'm going to use, how about blue and green? Why not? Blue and green. All right, so I'm going to do blue in my first one. So I'm going to graph these. Negative 2, negative 8. 1, 2, 3, 4, 5, 6, 7, 8. Negative 1 and negative 6. 1, 2, 3, 4, 5, 6. 0, negative 4. 1, negative 2, and 2, 0. Okay? And I'm going to just connect the dots. So far, so good, right? Nobody should be confused. I'm going to do my inverse in green. I like colors. So I'm going to go negative 8, 2. So back 8, down 2. Negative 8, 2 is a point. 1, 2, 3, 4, 5, 6, 7, 8, down 2. Okay, all right, there we go. Negative 6, negative 1. 1, 2, 3, 4, 5, 6, negative 1. Okay. Negative 4, 0. 1, 2, 3, 4. Negative 2, 1, and 0, 2. Okay. So they're opposites of each other, right? That's something to remember. So I want to write a couple of things down. Okay, so one thing I want to write down is from my blue graph, my original. So from my original, my blue graph, blue, or we'll call it f of x. And then for my green, which is f inverse, okay, f inverse of x, okay. Let's see if we see a couple of things. Okay, what do you notice? You see, they're opposites. Okay, first of all, do you notice anything? There should be something that you see right up there.
Yeah, different slopes.
Boom, that's what I was looking for, right? You guys agree? Different slopes. This one's going to be up 1 over 2, up 1 over 2. This one's up 2 over 1. So they're kind of like the opposite slopes. Does that make sense? So they're reciprocal of each other? Good. Nice job, Scott. I agree. So the first thing I know on slopes, they are reciprocals. Right? Because this one's going to be up 2 over 1. On the blue graph, it's up 2 over 1. And on the green graph, the slope is up 1 over 2. Awesome. And one other thing that I showed you guys is that the x-intercept of one is the y-intercept of the other. Okay, so here's my x-intercept becomes a y-intercept. Okay, so my and of the other, my y-intercept is my x-intercept. Okay, so the x-intercept is the y-intercept, and the same thing, the y-intercept, I'm kind of saying the same thing twice, right, becomes the x-intercept. Okay, so far so good. Now the equation of the green line, that's just a y equals up 1 over 2 x plus 2, right? That's the equation of the green graph of the original. And what's the equation of the blue graph? What's the equation of this graph?
Y equals 2 minus 4.
Yep. So Scott, you had a really good observation on the first one. The first one was way too easy. So it's not exactly what we thought, right? But the slopes are definitely going to be the opposite. Okay? But the y-intercept, not necessarily. Okay? It depends on where it starts, right? Okay, how am I doing? So far so good. It's pretty easy, right? Turn the page. Okay, example 2. Graph y equals 1/2 x minus 2 and its inverse. Okay, so I can do that. Do it in blue. Let's start at -2, right? Slope of up 1 over 2, up 1 over 2, right? It's my original. Now it's inverse. Well, we don't need every single point, do we? Let's be smart. I told you that the y-intercept, I'm sorry, the x-intercept becomes the y-intercept. This point right here, see where my finger is? It's got to go there. And this point right here is going to go there. Because I don't need to put every single point down, do I? We know that it's going to be a straight line. 2 points should do it, right? 2 points should do it. So I'm going to write that down. So what I'm going to do is I'm going to switch to graph f inverse of x. That's my inverse, right? I'm just going to switch x and y intercepts. All right, I'm going to circle those points so you guys can definitely see, okay? See what I'm talking about, okay? This is an x-intercept. X-intercept. Because this is the x-axis, right? That's the x-axis, x-intercept. This is the y-axis, so y-intercept would have to be right there. There's my y-intercept. So my x-intercept becomes a y-intercept, right? And this y-intercept has to become an x-intercept. So I'm at -2, I'm at -2, right? This had -2, so it's got to be a -2 on the x-axis, right? There's my x-intercept. All right? Okay, how am I doing? Now, what's the equation of my inverse? What's the equation of this green line? Yeah, Tava, you can answer.
Y equals 2 over 1 x plus 4.
Yes, and I'm going to take it a little bit further. Yes, I would never mark. I like this better. I'm not. This is awesome, by the way, but I like this better. You like my symbol? Nice. Yes, yes, yes. Everybody agree with that? All Tava did was she just walked the point up. She just said, hey, I know the slope is, you know, you can do up 2 over 1, up 2 over 1. Plus, we also knew it had to be the opposite of this one, right? Maybe the opposite of that one, and then have the y intercept before. Good job, Tava. Okay. How am I doing? Are we doing okay? Does it seem kind of easy? Okay, so one thumb up, any more thumbs up? Easier than piecewise graphs? Because we spent 3 days on piecewise graphs, didn't we? 3 days on it, right? We're only do 1 day of this, okay? Okay, now, example 3. F, x, and y are the same thing. So let me do myself a favor first. Let's change this. Let's change this to y equals 3x minus 12, okay? Now I want the inverse, which means I need its equation. This question did not ask me to graph it, right? I just want the equation. This one's actually pretty easy if we think. I don't want to graph it. What we're going to think. Oh gosh, it's early morning, Monday morning. I don't want to think.
You could change, you could divide dx by, could you,
You're thinking.
there.
Gretchen?
Wouldn't it be 1 over 3x plus 12?
You're really close. You're really close. You got the slope right. Here's what I'm going to do. Instead of switching points, x, y, x, y, x, y, x, y, if I switch the x variable and the y variable, now hear me out. The x variable represents all the x's. The y variable represents all the y variables. If I just switch the x and y variable, just switch them. I have the inverse. Check it out. I'm just going to do this. So instead of switching point by point by point by point, I'm going to switch them all. So what I'm going to do is this. I am going to switch x and y to y and x. So I'm going to write this. X equals 3y minus 12. I just switched them all. See what I did? Instead of y, I wrote x. So x or y. That's all I did. This whole thing's all about switching x and y. So now, this is not really the form I wanted. I want it to be in a better form, right? So I'm going to solve for y, okay? How do I solve for y? Solve for y right there. How do I solve for y? What should I do? I want to solve for y. Y is right there. How do I solve for y? There's y. How do I get rid of this 12? Let's go plus 12, plus 12, plus 12, plus 12. So we're getting x plus 12 equals 3y. Good. What do I do with this 3? Divide everything by 3, right, Miles? Everything. And there's our 1/3 because we've got an invisible number, right? Invisible. There's our 1/3. So Scott, you said 1/3. Gretchen, you said 1/3, right? Plus 4, though, equals y. And finally, the last thing I'm going to do is, and I would take this on a quiz, but I like this better because it is the inverse, okay? Okay. Now, one last thing I want you to look at, okay? One last thing I want you to look at, okay? So if we go to our journal, okay, real quickly, I want to look at one last thing and I'll be done, okay? Okay, I want to show you one last thing in our journal, okay? All right. Let's look at number 2 on page 15. Okay, number 2 on page 15, okay? And I'm going to just do a really rough graph, just a really rough one so you can see it, okay? It just is going to be a rough sketch, that's all, okay? Okay, 1 goes to 6, so 6 is about here. 4 goes to 3, maybe is here. But 4 also goes to 0. And 8 goes to -1. 17 goes to 13. Well, first of all, there's a problem with this, isn't there? Can anybody tell me what the problem is? Yes, Miles? It's not a function. So if it's not a function, has no inverse. No inverse. It's not a function, doesn't have an inverse. Let's look at number 2, or number 1. I want to look at number 1. Okay, so let's see. Switch them around. I'm going to make negative. I'll go 4, 2, 2, 5, and 3. I'm going to go -3, -1, 0, 1, 3. Okay. All right. You guys, I want you guys to go here in a minute, but before I go on, there is a problem with number 2. Or, I'm sorry, with number 1. There is a problem. Does anybody see the problem with number 2 or with number 1? Yeah. What do you see?
It's also not a function.
The original is a function, right? I mean, the original is a function. But this can't be a function because 2 can't go to -1 and 2 can't go to 0, right? So -1 can go to 2, 0 can go to 2, 1 can go. So this can happen. It's like having lattes, 2 for the price of 1. Does that make sense? This can happen, but this can't happen. So even though this is a function, this one's not. So this one does not have a function either. This one's called a relation, not a function, okay? So we're going to say that this one is a relation, but has no inverse. Okay, so here's our homework for today. We're going to do page 15 and page 16. I want you to do all of them. I want you to do 1 through 12, all in your journal. So page homework is page 15 and page 16, the 1 through 12, all, okay? All right, and that's all I have. And I know some of you guys got to go, but I'll see you tomorrow, okay?